Welcome to another session of INF154. So for this session, we are going to continue with our discussion on decision making. So the prerequisite of this video is that you watched the first video that I made regarding decision making. So for this video, we are going to go into detail when it comes to if statements, nested if statements, switch statements. So I'm not actually going to code, I'm going to go through the theory. So we are going to start with logical expressions. So logical expressions use logical operators that take one or more operands of Boolean type and creates a Boolean type. So these these operators, they take one or more Boolean expressions and create a final Boolean type. So at the end, they will return a true or false. So when it comes to logical operators, we have three types, which we should know by now. So we have the not, which is represented by this exclamation mark, and we have the or, which is represented by these lines, and we have the and, which is represented by this ampersand operator. So we have this logical, this is called logical not, this is called logical or, this is called logical and. So from the previous video, we know that we covered the relational operators and the equality operators. So relational operators are your less than, less or equals to, greater than, greater or equals to. Your equality operators are your equals to and not equals to. Then the order of precedence. So the order in which expressions are evaluated. The one with the highest precedence is your not, so it has the highest precedence over these others. Then these relational operators have the same precedence, which is 11. Then these equality operators have the same precedence, which is 10. Then the and has a precedence of 6 and the or has a precedence of 5. So if you are given like Boolean expressions containing these symbols without like brackets, you have to follow the order of precedence. So this is from highest to lowest. So the highest is not, followed by the relational operators, followed by the equality operators, followed by and, followed by or. So we are going to consider the truth tables for these three logical operators. So for not, so if you have, it takes one operand, the not takes one operand. We discussed what's an operand, I think, back then. So if something is not true, it's going to be false. Something that is not false, it's going to be what? It's going to be true. That's your not. So not true will give us false, and not false will give us true. So the not, it only gives you the opposite of what you have. So not true, it's false. Not false, it's true. Then we have the or. So with the or, every time you see at least one true, the expression is true. So these are the possible combinations for your or. So on your left you can have a true, on your right you can have a true. So true or true, it's a true because we have one true or at least one true. So here true false, at least we have one true, so the whole thing will be true. Then false true, we also have one true, everything will be true. False false, we don't have a true, so everything is false. So or it's only true if at least one operand is true, otherwise it's false. Then we consider the and. So for the and, we have when you have your left and right operands, you can have let me just change this. So if you have for and you must both conditions must be true. If you see one false, everything is false. So it's the opposite of this sort of. So here I have true, true. So there's no false. Everything will be true. True, false. One false, everything becomes false. False, true. One false, everything becomes false. False, false. As long as there's one false, everything will become false. That's your AND operator. Now we can evaluate Boolean expressions. So it's important to know how to evaluate Boolean expressions before going to if statements. So if you are given not, then true, the result will be false because it's not true. So it's false. Not false, the result will be true because this was false and we used not. Not gives us the opposite of what we have. So here we have 3 less than 5 and 4 greater than 7. You see now we don't have brackets. We have to use the order of precedence. We know that AND has a lowest precedence compared to these comparison or relational operators. So we have to evaluate this and this first because they have the highest precedence. So is 3 less than 5? Remember, this is all about true or false. You ask yourself, is 3 less than 5? Yes, 3 is less than 5, so the result will be true. Then we evaluate the others. 4 greater than 2. Is 4 greater than 2? Yes, it's greater than 2, so it's true. So true and true, everything is true and it's an AND. So it's going to give you true. Then we can go to this one, 4 less than 6 and 2 equals to 3. Now we ask ourselves, is 4 less than 6? Yes, this is true. Then is 2 equals to 3? No, this will be what? False. So you have true and false. This is an AND. If I see one false, everything is what? It's false. So the result will be false. Then we have 4 less than 5 or 4 less than or equals to 3. So we evaluate again. Is 4 less than 5? Yes, 4 is less than 5 and it's true. Because it's an OR, there's no need for me to evaluate this. Whenever I see one true with an OR, everything is true. So the result will be true. Even if you evaluate this, at the end is going to be true or false, which is true. Then let me see if I can go through some examples. Let me check here. So here are a few examples of so let's evaluate this E, the last one. So we want to evaluate E, which is the last one. So I'm just going to do this. So I have this. So every time I have parentheses, I have to evaluate what's inside the parentheses. So I have to evaluate this, evaluate this, evaluate this. So mathematical operators have a higher precedence compared to relational operators. So here we have x less or equals to y minus 2. So we have to, so the assumption was that x is 10, y is 15, z is 20. So we have to evaluate. So in this case, x is 10. So this is 10. So y minus 2 is 15 minus 2. So 15 minus 2 is 13. Then we ask ourselves, is 10 less or equals to 13? So it's true. So we can evaluate this, y greater or equals to z. Then we ask ourselves, is y, which is 15, greater or equals to z? No. So this is false. So this is a false. Then I evaluate this, z minus 2, it's 18. Is 18 not equals to 20? yes, so this is true. Then I have a true, I have false, I have a true. Then I have two uh, operators, logical operators, and or. So I have to use the precedence. We know that and has a higher precedence than or. So we have to evaluate this first. So we have to start with this. So true and false. So this is an and. We have one false. So everything here will be what? Will be false. Then now we are left with false or true. So because it's an or, everything will be true. We have one true, so the result will be true. Then as a challenge, you can try the remaining. You can try this. You can take a screenshot and try these other ones before you proceed to the other part. So now we are ready to move to if statements. So we are going to start with the if statement, which is a one-way selection. So with the if statement, it's either we do something or we don't do something. It's either we do something or we just avoid. For example, let's say you want to go outside and you want to decide if you want to wear a jersey. Let's say initially you didn't wear a jersey. So you are going to go outside, get the temperature as your input. You ask yourself, is it cold? If it's cold, you are going to wear a jersey. But if it's not cold, you are just going to ignore because you are not wearing a jersey. So you ignore. That's how the if statement works. It's a one-way selection. So it's if, then you have your condition. This condition, it's your what? It's your Boolean expression that you open this, close, then you put like some statements here. So these statements, it's code. It can be multiple lines of code. It can be your loop. It can be like any code that you want. Then let's say you have your next instructions. So the flow diagram of this is that okay, you come from the beginning of your program where you declared variables and stuff. Then when you reach this if statement, now it's a decision. So a decision is represented by this diamond. Then you put the condition. Then you ask yourself, is the condition true? If the condition is true, you are going to choose this path. You are going to execute what these statements. Then you just go here, then you execute the next instructions. So this is a matter of selecting like a path to execute. So if the condition is true, we do what? We execute this. We choose this path. Then if the condition is false, we just ignore everything, then we execute the next instruction. So if the condition is true, we choose this path, then next instruction. If the condition is false, we just ignore everything, we just go to the next instruction. So this is your one-way selection. So do a task or not. Then the pitfalls. Let me just demonstrate some of the pitfalls that people make. Let me do this. I'm just going to use an online compiler. I don't want to go to the process of creating forms and stuff. So I'm just going to use an online compiler. So let's say int age. So this program will take the age from the user. Let's assume that it will take the age from the user with your Visual Studio Code, whatever. So for me, I'm just going to set it. Let's say age is equals to 10. Then I want to write a program that will determine if the user is old or what. So string age or string let me say output is equals to an empty string. Then I'm going to say if my age is greater than or equals to 18, I know that the user is old. So output is equals to old, something like that. Then let me see, what did I do wrong? Let me remove this. Then at the end I can just print this. Then I can see output. Let's see what's going to happen when I execute this. Let me see, what did I do wrong? Console dot, I forgot a semicolon here. Then let's execute again. End of file, end of file. So this is my, I guess I had to close this, something like that. Then let's execute. Yeah, something like this. So my age is 10. I ask myself, it's 10 greater or equals to 18? No, so this will be false. It's going to ignore this, then it's just going to print the output. That's why we have something that is empty. Then now let's change the age maybe to 20 whatever. Then we execute this. It must give us old. You see, it's old because age is greater than or equals to 18. 21 is greater than 18. So I'm not here to demonstrate the code. I'm here to give like some of the pitfalls. So the first mistake that people make is to use 1 equals to here. So this is wrong. You can't use 1 equals to. 1 equals to, it's used for assigning or storing values inside variables. So if I execute this, the code must crash. So it did crash. So it won't work. This is a syntax error. So let's do another thing, another pitfall. Maybe you put a semicolon immediately after this closing bracket. This won't work. Your code will crash again. So you see, actually it's running, but it's giving a wrong output, because when you say if age is greater than or equals to 18, then you put a comma. We call this an empty if statement. So this is an empty if statement. So there's nothing after the if statement. Whatever comes, it's no longer part of the if statement, because when you see a comma, it's a termination. So that's a mistake. So you have to be careful about that. Then the next thing, you can do this if you have one line. This is absolutely correct. If you have one line of code, this is correct. Then if I execute this will work fine. Then if I put, let's say you say output plus equals to maybe age, something like this, then this won't work. It will work, but it's going to execute this, but the second line is no longer part of the if statement. For example, if I change age to, let's say 1, we know that 1 is less than 18, so our expectation will be like these two statements won't be executed. But let's see what's going to happen. You see, this other one was executed. So if you have multiple lines, it's a must to put your code in between these. If you have one line, it's valid to remove this and just put this. So those were some of the pitfalls when it comes to those things. Then now we can move to the two-way selections. So we have the if else. So we saw that that code that we wrote, it indicated that a person is old. What if they are young? We can't just ignore. So that's where the two-way selection comes. So you say if, then you put the condition. This condition is your Boolean expression or your Boolean logic. So if that condition is true, you are going to execute statement 1 and ignore everything that's part of the if statement. So, but this next is not part of the if statement. You are going to execute it. So let's see how it works. So you are going to come again from your program, declaring variables, what. Then when you reach this code, the if statement, you have to ask yourself, is the condition true or false? So if that condition is true, what are we going to do? We choose this path. We execute statement 1. Then we just continue with our program. So we are choosing this path. It's about choosing a path. So it's all about choosing a path. Actually, you just choose this true path. So you are going to execute this. If this condition is true, you execute this. Then you ignore everything that's part of the if statement. You don't ignore the whole program. You ignore this else. We know it's a part of this if statement, so we can ignore this. But this next is not part of the if statement. We are going to execute it. So what if the condition is false? If it's false, we consider the else part. We execute the else part. So we are going to choose this path. So now here it's like you have two options. You can either choose this path or you can choose this path. Think of it as a sort of like when you are, let's say you have a road. Then your road, you go straight. Then here you get like sort of like two paths, something like that. So you get something like this. Then the path that they meet, something like this. So it's like you come from here. Then when you get here, you have to decide whether to turn left or turn right. When you turn right, you just continue. Then you just continue. If you turn left again, you just take this path. But at the end, you are going to reach the same point. That's how they work. You just choose a path here. It's either you choose the truth path or you choose the false path. Then we have the short circuit behavior. So you have to be aware of this. So C# tries to be as efficient as possible. So works on logical OR and logical AND. So logical AND, if the first operand is false, ignore everything. So everything is just false. This is what we explain. If you get your first false with an AND, then everything it's false. Like if you have your AND, I can't draw properly here, but yeah, but with an OR, if you get your first true, everything is true. You don't have to execute other things. For example, if let me see here. I don't have like multiple. Let me check here. Like for example, let me just go here. You see here, if number was less than 0, let's say if the number was -1, is -1 greater or equals to 0? No. So we stop because it's an AND. There's no need to evaluate this. So this is what we mean by the short circuit thing. Then we have the multi-way selection. So here you have your multi-way selection. It's your if, else if, whatever. So with the multi-way selection, you are testing like multiple conditions. So if condition 1 is true, you execute this. Then you ignore everything that's part of the if statement. Then you can continue with the next instruction. What if condition 1 is false? You test the second condition. If the second condition is true, you execute this and ignore everything else. What if condition 2 is also false? You also test condition 3. If condition 3 is true, you execute this, and if it's false, you just execute the else. The else, notice that the else doesn't have opening and closing those brackets because it's a default. If everything fails, it's sort of like a fallback. If everything fails, then we execute the else part. So let's see how this works on the flow chart. So we are going to start your code as usual, then we hit this line of code, then we test condition 1. If condition 1 is true, we choose this path, the S1 path. We ignore everything, we ignore, think like the way I demonstrated with that thing of choosing like which path to take. I can't seem to find it, but yeah, we choose this path, then we ignore everything. Then if that condition is false, if condition 1 is false, then we just go down, we get the else if, so we test the second condition. So if that condition is true, again we are going to choose the S2 path to go to the next instruction. So we choose the S2 path to go to the next instruction. We ignore this, we ignore this, we choose the S2 path. What if the second condition is also false? Then we just go down. So we go down again, we see else if, we test the third condition. So if the third condition is true, we choose that S3 path. So we choose that path. Then if everything is false, we just choose the default path. So we choose the else path. So this else is optional. This else is optional. You can just write else if, else if, else if, and leave the else path. So it's just, it depends on the code. Then we just continue moving to the next instruction. Notice that if the next instruction is an if statement again, if something, we are going to execute it because it's a new if statement. It's no longer part of these ifs. If you put if after this if else what, if you just put a new if, it's a new if statement, it's not part of that, you test it. That's another important part. Now we can move to what? To nested if statements. So nested if statements is when you have if statements inside if statements. So for example, if condition 1 is true, we know that we have to choose this. If condition 1 is true. But inside condition 1, we have another condition that we need to test. So if condition 2 is true, we choose this path. Then otherwise we choose this path. But what if condition 1 is false? If condition 1 is false, we ignore everything, then we go to this path. So in this path we check again, is condition 3 true? If condition 3 is true, we choose this, otherwise we choose this. Then anywhere we end, we are just going to continue with the next instruction. So let's see the flow diagram for that. So again, you start normally with your code, start, then you reach this line. So we test condition 1. If condition 1 is true, then we choose this path. Then in this path, yes, we move smoothly. We move, then we reach this line. Notice that if we had other lines, maybe message box.show, or any line that is not like an if statement, we were going to execute that specific line because we don't make decisions there. Normal execution flow. But here we have an if statement, we have to decide, like we chose this path, then in this path again we decide, is condition, we have another condition, is condition 2 true? If that condition is true, then we choose the S1 path. So we choose that S1 path, then we just go to the next instruction. Notice we ignored everything, we just chose a path. It's all about choosing which path to execute. So if this is true, we execute S1, then we are done. We are literally done. Because if this is true, automatically we ignore the else path. Then we are inside here. If this is true, we execute this, we are done. Else we execute this. If this was false, we execute this. So if this was true, then the second condition was false. We were going to choose what? The S2 path. Then at the end we move to a next instruction. Then what if condition 1 was false? If condition 1 was false, we were going to choose the else path. So we are choosing this else path. We ignore everything, which we are choosing the else path. Again, in the else path, we were working smoothly. Then we reach an intersection. Now we have to decide, do we want to turn left or right? Something like that. Then we test condition 3. Condition 3 again, if it's true, we are going to choose this path. Then next instruction. Otherwise, if that condition is false, we are going to choose this other path. Then you can play around with this diagram. You can take screenshot or whatever and play around with this diagram. And inside this, it can be like one-way selections, multi-way selections, and you can put you can nest an if statement again inside this, so it can be as complicated as possible. Then now we can move to the last part, which is your switch statement. So a switch statement is a special type of an if statement. So the prerequisite of a switch statement is this kind of if statement. It's similar to this. It's the same as this if a multi-way selection if statement. So you must have a. First you are saying if a is equals to b, we execute S1. Notice we have a, right? Then let's move to else if a. You see, it's all about a here. Then else if a again. Then another important thing is what is the equals to. So if a is equals to, that's the basics. You cannot use the switch statement when you have greater than, when you have less than, when you have not equals to, or when you have anything other than equals to. You must have always on your left, it must be the same variable. Then on your right, it must be like different values. So in this case, if a is equals to b, else if a is equals to c, else if a is equals to d, then else. Then notice with the switch statement, we put a switch. That's the keyword. Then you open, then you close. Then you put a. So the variable that you are on the left that you are comparing to. So this in this case is just a. So we put a. Then now we can choose. So if a is equals to b, when you say case b, it means if a is equals to b. So if a is equals to b, that's case b. When you say case b, it's going to compare this a and b. So if a is equals to b, what do we want? We want to execute S1. So in this case, we choose S1. Then ignoring everything in a switch statement means break. So it's important to put break. Break, it's for ignoring everything else. If you ignore the break, you're going to get an error. So you must put the break. Then again, else if a is equals to c. So case c. So if this a is equals to c, we are going to execute what? S2. So this is the S2. Then when you are done, you ignore everything. It's break. So for if statements, this break is automatic, but for the switch, you have to explicitly write the break. Then else if a is equals to d, if a is equals to d, so if a, then case d, it means if a is equals to d, then you execute this, then you break. Then the else, it's indicated by default. Notice that it doesn't have d what because the else doesn't take anything, so it's just default. Then you put S4, then you break. Then let's see a practical example or an example of this. So we need to convert this if statement into a switch statement. So now if A plus B is equals to C multiplied by B, then we choose this path. Else if A plus B is equals to the sum of these, then we choose this path, right? Then else we choose this path. So we want to convert this into switch, or we want to rewrite this using switch statements. So we know that, okay, A plus B, yes, it passes. A plus B, it passes. Then the else, it passes. So this is going to be switch. Then what are we putting inside the switch? It's A plus B, because on the left it's A plus B, A plus B. So we have case. So A plus B, if A plus B is equals to C multiplied by B. So this is case C multiplied by B. What are we going to do? We are going to put this block. Then we ask ourselves, can we convert this into a switch? No, we can't, because this is not equals to, and we don't have an else, something like that, but this is not equals to, so we cannot do that. That's why we rewrite that as it is. Then after that we break, because we were at case that we have to break at every case. Then now we check the second part. So case C plus D plus E is this. So we can say case C plus D plus E, then we put break just to not confuse ourselves. Every case comes with a break. Then we have to convert this, if it's possible, to a switch statement. Then we check, okay, we have this A equals to 1, A equals to 2, then else. So A then equals to, so it's possible to convert this into a what? Into a switch statement. So case 1. So if A is equals to 1, we are going to do that. So we are going to say output equals to A. That's it. Then we break, because it's for that case 1. We break. Then else if, so this is our case 2. Then again the output equals to B. Then we do what? We break. Then the else is our default. So default, then we break. I forgot to break here, so you must break here. Then we are done with the big with this case and its break. Then now we can go to this else. Then we can just rewrite. This is our default one. Output equals to A. Then when we are done, we do what? We break. Then yeah, I think that's all for this video. I'm going to end here for this video. I don't think there's much to it. So yeah.